Hello, everyone. Thank you for attending our presentation on renovations to the existing James Cole Elementary or JCE school to make it net zero energy. We are participating in Design Partners pilot program this year and have worked closely with the school and local contractors to identify a number of cost-effective renovations that will save money for the school and improve educational outcomes for its students. More importantly than just this one school, we are presenting a prototype for improvements that other school districts should follow. We call this idea Phase Net Zero, or P&Z for short. Before we run into all the details for renovations, let me introduce our team to you. My name is Songhao Wu, the project lead. Today we have me, Zach, Brian, Bobia, and Amelia as presenters. However, Henry, Namrasa, James, and June are also important members of the team. Here's the outline for our presentation. We're going to address our renovation project in order of architecture, comfort, indoor environmental quality or IEQ, engineering, operation, energy, innovation, resilience, financial feasibility, and market potential. Let's talk about the school first. JCE is at Stockwell, Indiana, where the climate zone is 5A. It is managed by Tippecanoe School Corporation, which is the fourth largest school district in Indiana in terms of its size and student numbers. It is an existing school built in 1988 with an advanced mechanical system and thermal features compared to others built in the 80s. A 13-acre area enclosed by the red line on the right pictures was used for this project. Our project is about coming up with ideas to renovate the JCE in phases to achieve net zero energy. When we were first given this project, we were excited because JCE is about 30 minutes from Purdue, and we went there for field trip immediately. We were thrilled to jump in to come up with unique designs. Our designs totally focus on the current building occupants at the JCE. For students, we want to bring a sense of nature inside the school for mindfulness and teach them the idea of sustainability, especially those related to energy conservation. For teachers, we want to give them a better understanding of the teaching environment. We sent a survey to ask their ideas for indoor environment and teaching. They think improving indoor environment could enhance kids' learning ability. They also want to teach kids about the outdoor environment. We come up with the idea of using Biowall to help them teach students about how nature could play a role in an indoor setting. As for staffs who clean and maintain this building, sufficient training program could help them to better understand and run the school in a more efficient way, both in the finance and energy sense. Focusing on occupants' needs and contest criteria, we developed 6 design goals. Primarily, we wanted JCE to be a net zero energy school through phased renovation and serve as a model for other schools. We developed the phased model or template for other schools to achieve net zero energy, so existing schools could have a school template to refer to when they have the need to carry on renovation projects to be net zero or more energy efficient schools. Based on the phased energy saving opportunities, we want to teach the idea of sustainability to both students and the facility staff at JCE. As for mindfulness, we evaluated the architectural traits of the school and proposed phased modification like a lighting retrofit and a biowall to enrich education quality and further enhance kids' ability to learn at school. In the case of disaster, JCE could be a community recovery center. Those designs don't mean anything unless we could actually build them. We dedicated one team member to perform comprehensive financial analysis and calculated the return of investment on each phase renovation idea to determine which one to carry on first. Now I'll pass on to Emilio to address architecture sections of our project.
Thanks, Sungal. So James Cole is an existing building that already has a good design. So this means that the range of architecture interventions that we could do is limited. However, even though the occupants enjoy the current features, we propose certain innovations that will enhance mindfulness and wellness in the students. Here you can see the efficient layout of the school that is designed with a sort of neighborhood concept. At the center in white, you see the entrance lobby and atrium, which act as a nucleus of this neighborhood. This center leads to the corridor that goes east and west, connecting all the other spaces such as classrooms, cafeteria, and library, among others. You can see that most of the rooms that will need more daylighting for comfortable purposes are located on the south side, such as the classrooms and the library. In the next slide, here are some existing features that current occupants enjoy. The building itself has high and varied ceiling heights in the common spaces, which give these spaces a sense of freedom and openness. can see on the picture on the top left that there are high clerestory windows allow daylight to reach far into the common spaces. And as I mentioned before, 13 of the 16 classrooms have south-facing windows, but because of the earthburn feature that wraps around the building, windows in these classrooms are located high up on the walls, meaning that light can enter and reach a longer distance to the interior. This earthburn feature is 3 to 5 feet tall at different parts and acts as an efficient natural thermal barrier, conserving heat and energy inside. In the next slide, the exterior facade is shown. The subtle colors are consistent on every side, which all resemble and blend into the cornfields and landscape that surround the school property. The green metal roof panel relates to the green fields, and the yellow beige-ish brick walls resemble the corn. The proposed addition to the roof will have the same green tone and will be better insulated, which will provide better acoustic protection from exterior noise, such as rain hitting the metal roof. Now I'll hand it to Bhavya to talk about indoor environmental quality and our proposed features.
Thanks, Emilio. As we know, James School is an existing building. We wanted to know the perspective of the teachers and facility staff on the indoor environment quality. So we conducted an online survey. The results showed that they're quite satisfied with the physical structure, but are not highly satisfied with the air, light, and sound quality. In this slide, you can see the graphs which we got from the survey results. On the right top, you can see that the respondents gave a score of 6.3 on 10 on air quality, while 40% are not quite satisfied with the lighting levels, and some of them even associated sound with echo. As these factors can affect the cognitive and mental well-being of the occupant, it gave us a clear understanding of the interventions we need to do at James School. So the design interventions we are proposing are more towards enhancing the space quality rather than redesigning the structure itself. To improve sound quality, we will install acoustic barriers or sound baffles in common areas and classrooms. The geometry of these will be inspired from nature, with the intention that to teach students about nature from the building elements. Natural lighting levels will be enhanced by installing smart LED lightings, and which will be discussed more in the next slide. Biophilic elements like biowalls, planters will be incorporated inside the school space, which in turn improve the air quality. At the same time, bring in the sense of nature to the occupants. To enhance visual quality of the spaces, colors and textures will be added into the space to stimulate the students' learning. Though James School gets a lot of natural light, it does not reach all the areas with same intensity. So to tackle this issue, we are proposing LED lights with occupant sensors connected to it. These lights, if you can see on the left side, these lights are divided into sections which are with proximity to the windows. The figure shows the yellow color line is the daylight, the blue is the light from the LED lights, and green is the total light. Here you can see section 2 and section 3 lights are turned on to get equal intensity of the light in the spaces. In the future, they can even be connected to daylight sensors and dimmers for better performance. And we recreated some of the interior spaces by adding the proposals which we proposed. Here, this is a classroom visual. We added sound baffles which are in the shape of a beehive, and we use warm colors to make the space more cheerful and stress-free for the students. And in the lobby area, the main concept is neighborhood concept. So we wanted to reinforce it. To achieve this, we added different seating options and have different arrangements of it. And also we brought in colors like colors like green through the planters and orange from the sound baffles to make the space more welcoming, warm, and socializable. And this also brings in a sense of this also integrate the nature in the building. Now I'll pass on to Zach to talk about engineering and operations.
Thank you, Bhavya. Engineered with energy efficiency in mind, the single-story, double-stacked corridors are ideal for heating and cooling, with all rooms having external wall or roof exposure, reducing thermal reservoirs. A geothermal well loop is used for heating and cooling throughout the school, as well as individual zone heat pumps. The heat pumps are connected to the well loop as shown for zone heating and cooling based on demand and well field temperatures. The intelligent engineering design of zone heat pumps allows for individual zone conditioning, heating northern classrooms while cooling southern classrooms on a sunny day in spring, providing comfortable and efficient indoor environmental quality. Proper ventilation is another key factor in IEQ and engineering design. Ventilation is provided by a central makeup air handler delivering 8,000 CFM of air into the school. The air handler has a built-in heat recovery system that provides 70% of conditioning of the outside air, saving 70 megawatt hours of electricity annually, as shown by the graph to the right. The green area represents the heat recovered by the heat recovery system, and the red is the additional heating provided by the individual zone heat pumps. Proper monitoring, maintenance, and operation of the building systems are key to maintaining the energy efficiency design of the school. A building automation system is used to operate, monitor, and maintain systems efficiently within the school. The lighting, HVAC, and hot water distribution are scheduled on during school days and turned off outside school activities, saving energy. An investigation of the BAS found the propane boiler switched on 24/7, consuming twice as much energy as normal, as shown by the graph on the right. This identified the opportunity for a recommissioning of this building systems, as well as additional training for facility staff. We propose the use of key performance indicators, as shown at the bottom, to simplify monitoring for staff and identify areas of concern quickly. Proper scheduling and management of the building systems help reduce cost and improve energy performance. In 2018, JCE consumed 500 megawatt hours of electricity, resulting in an EUI of 94, as shown by the graph on the left. Comprehension of the building architecture, engineering, and operations led to an energy audit of the building, identifying opportunities for improvement to reduce EUI from 94 to 57 through energy conservation renovations. The financial analysis will ultimately dictate what opportunities are implemented. The pie chart on the right provides these expected opportunities for energy savings. The building envelope upgrade will provide 37% of energy savings roughly by increasing the roof insulation and improving the windows. Recommissioning of the building systems and staff training to monitor and maintain operations will provide roughly 25% of energy savings. Plug load reductions will result in roughly 25% energy savings by reducing equipment use and replacing old equipment such as old dairy coolers and the current walk-in refrigerator, which is being phased in right now. With 75% of the school still using fluorescent lighting, 10% of energy savings can be achieved by continuing to phase in dimmable LED lighting with occupancy sensors. Replacing the hot water boiler with a distributed tankless water heater system will provide an additional 3% of energy savings roughly, providing on-demand hot water and reducing heat losses. After accomplishing all energy conservation measures, installing a ground-mounted solar PV array will bring JCE to an EUI of 23 and achieve net zero. A 300 kilowatt DC solar PV array will be located south of JCE as shown in the bottom left photo, welcoming all to the school. The graph to the right shows the energy consumed by JCE in 2018 and the expected energy production of the solar array according to PV Watts calculator on a monthly basis. This array is expected to produce 400 megawatt hours of electricity annually, 80% of JCE's 2018 electricity use. By implementing energy conservation measures and installing this solar array, net zero energy is attainable for JCE through phased-in renovation efforts. I now will pass it on to Song Hao to discuss innovation features.
Thanks, Zach. Renovating an existing school to achieve net zero energy is a significant challenge. It is difficult to propose solutions that can be accomplished within the operation and the cost constraint of a busy school. Biowall is one of the simple devices that are relatively cheap but could enhance the mindfulness of students while improving air quality. Mindfulness means creating a learning environment for students that is safe, reduces stress, and allows students to be in the present moment. Large areas of green plants indoors could definitely make students feel relaxed. The Biowall on the left is based on a US patent Purdue University owns. Biowall consists of plant trees with a fan that pulls air through it. There's various plant options like aloe vera and spider plants. The soil is a loose packed growth medium that allows airflow. This system can be connected to the HVAC system of a building so that it can recirculate air through the ductwork. But for JCE, it will likely to use an independent air filtering system like an air purifier. We're envisioning modifying current biowall to be a flat strip of green plants built along the wall shown on the right so students can see them, feel them, and even water them. You will take advantage of JCE's unique celestial window for daylighting and is most likely to be put in a corridor. A biowall controller will still regulate the fan and monitor humidity, temperature, and the VOCs. It also enables fan cycles, water leak detection, emergency shutdown, and data display of overall IEQ. Now I'm going to pass over to Brian to address resilience and financial feasibility.
Thank you, Songhao. In 2013, Southwestern Middle School, a school in the Tippecanoe County School Corp family, was struck by an EF2 tornado. On the picture on the right, you can see that it caused significant damage to the school, and it also caused terminal damage to a 50 kilowatt wind turbine. After analyzing JCE and all the risks, we felt that severe storms and tornado was the highest likelihood and highest risk to JCE, so we accounted for that in all of our designs. When it comes to the resiliency of the systems, we want to ensure that they can survive a severe storm or tornado and they can function on a moment's notice. The building automation system will be able to bring critical systems on and offline as necessary in order for the school to maintain function. The solar array will also be able to withstand winds up to 140 miles an hour and not cause any damage to anybody around. When it comes to occupants in the school, the picture on the right shows where the storm shelter will be. These rooms, the cafeteria and the gymnasium, have no external windows, which offer a great space for protection for if occupants are in the building. When it comes to using the school as a community hub, we talked to W.M. Anderson, who is the director of the Tippecanoe County Emergency Management Association. Due to James Cole's proximity to surrounding rural communities, he said it would be a perfect fit for a disaster hub if supplies are needed, regardless of whether power to JCE is on or off. Considering the times that are going on right now, we decided to analyze one of the things that we put as a very low risk, which is a global pandemic. We reached out to UV Resources in Santa Clarita, California, about the opportunity of installing UV lights in the primary air handling unit. This light of 200 to 400 nanometers will disinfect the 100% outside air that comes into the building. The equipment cost would be $4,200 with further costs coming in installation. Now I'm going to move on to talk about financial feasibility. When it comes to the financial analysis, you can see that we did full first-year energy savings, initial cost, break-even year, and the 20-year net present value for all of the systems and initiatives we plan on implementing. As you can see, they are ranked by a different priority level based on their payback. The plug loads, recommissioning, lighting, Biowall, and solar all offered a positive 20-year net present value, whereas the windows, roof, and hot water system did not have a positive net present value over 20 years. All of this comes down to priority levels of implementation. All of the ones with positive values will be implemented first, whereas the hot water, windows, and roof will wait to the end of life of that system. This is due to the budget and current financial assets that Tippecanoe County School Corp has, and in order to do a phased net zero implementation. Next, I'm going to show you the graph, which is on screen, showing you the Biowall, lighting, recommissioning, and plug loads over the 20-year life cycle. As you can see, in year 5, there is a positive net present value, and it offers savings of up to $550,000. Now, I'm going to pass it off to Emilio to talk about market potential.
Thanks, Brian. So in the rural Stalco community, James Cole Elementary is more than just a building. It can be a proud focal point and place for the community to come together. After analyzing the market, there are several things that show that the time is right for a push to net zero energy. Indiana's public school voucher program is one of the largest in the country, and this program is continuously growing, as you can see on the graph on the left. This limits the annual spending capacity for upgrades and renovations at James Cole and other public schools in the state. Another circumstance that is driving the push to net zero is that our client, Tippecanoe School Corp, is faced with rapidly raising energy bills put forth by the local utility company. With all this going on, Tippecanoe School Corp was considering installing wind turbines to produce energy, but these were then prohibited by the county, discarding that option. This all points to the growing pressure that schools are facing on their budgets. So the priority is to cut energy expenditures, and James Cole is a great place to start to pursue net zero energy, hopefully paving the way for other similar schools. Another key factor driving a proposal is the impact it will have on the occupants. Achieving mindfulness and wellness in both students and faculty is extremely important to ensure proper learning and education. We hope that the installation of biowalls throughout the school, as well as upgrading the lighting and acoustic levels, can help accomplish this mindset for the occupants. A further goal is to enhance the education of the students using the energy-efficient infrastructure and solar array we are proposing. James Cole could become a hands-on learning laboratory for STEM education, integrating the proposed sustainable systems into the learning objectives put forth by the Indiana Department of Education. The next slide, you can see that the team collaborated with multiple local vendors to propose solutions and technologies that could be readily available today. The extreme proximity of these vendors allows for enhanced affordability and productivity, while also giving us reliable and up-to-date pricing on the necessary materials. Next slide, you'll see our phased net zero plan. This plan tackles the significant challenges put forth by making improvements to an existing school. The first is that since school is in session for 9 months of the year, any intervention during this could jeopardize the safety of the occupants or close down parts of the school. This must be avoided, so work will have to be split up in phases around the school schedule, taking advantage of summer months. The second challenge is working within the available budget. Our proposed activities will have to be within the permissible annual budget set forth by the client, so they'll be split up and ordered by priority and impact on energy conservation, as Brian mentioned before. The last phase, or phase 4, has optional under it because acoustic and UV interventions are not considered essential to reach net zero energy, but instead are considered as key aspects to attain a high level of mindfulness and wellness. Because they are not needed to reach net zero energy, the school may choose to not invest the money in that intervention until a later date. Last slide is our ability to replicate this for other schools across 1, the Tippecanoe School Corporation, 2, the state, and 3, possibly even the nation. TSC has 19 schools, and with them being our client, it's important to have this net zero process that can be replicated, not just at James Cole. We developed this 5-step process with specific components to each that when followed appropriately, similar results could be accomplished. We hope that this comprehensive approach can achieve exceptional outcomes and also become a model or template for thousands of rural schools to follow across the Midwest. In our conclusion, this design is feasible and James Cole Elementary could proceed on the path to net zero with these recommendations. I'll give it back to Songal for some closing comments.
So in the end, we want to thank our client, Tippecanoe School Corporation, for giving us this awesome project and moving ahead with our phased renovation recommendations. We're confident that our comprehensive phased net zero approach can achieve great outcomes and become a model for thousands of rural schools across the Midwest to follow. And we also want to thank our kind industrial sponsor, Houston Electric, and other partners for helping us coming up with feasible renovation designs. Thank you so much. That's our presentation.